By the napkin math, if you could snap your fingers and imagine a world where every home had a battery like Pila, 1.5 kilowatt hours, kind of in one location that mattered a lot to them, whether it was their fridge, sump pump, home office, terrarium protecting their heat lamp on their lizard, which is one I've heard, right? We had one of these batteries in every home. We would hit almost 10x the total grid connected battery capacity today. In other words, the sum of all power walls in homes, the sum of all container-sized grid batteries next to solar fields. So there's a lot of power in distributed scale.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Cole Ashman, the CEO and founder of Pila Energy. At Pila, Cole and his team are developing a mesh home battery. We'll get into more about what that means exactly, but these are 1.6 kilowatt hour batteries that can be deployed around the house to back up critical appliances like your fridge. Similar to a whole home battery like Tesla Powerwall, they both provide energy resilience during power outages, but also enable homes to better utilize home solar systems or renewable electricity on the grid. One thing I think is so exciting about this is that because they're so much smaller and cheaper than whole home batteries, they lower the barrier to entry for people to get energy storage in their homes. To introduce Cole quickly, he studied both chemical and mechanical engineering in college and has spent his career really helping individuals build energy resilience at home. Prior to founding Pila in the last year, he previously worked at Span, building smart electrical panels, and Tesla on the Powerwall. So really two of the most impactful companies and products in the space. When I first met Cole, we talked for about 30 minutes and I came away feeling like I had a much better understanding of the world than when we started. So Cole, I'm really excited to be chatting with you again. Thanks a lot for joining the show.
Thanks, Dylan. Wow, what an introduction, truly.
Really, I appreciated that chat we had. And that was actually when you were still in stealth. And it's been really fun to see what you're doing, what you're up to. And I'm excited to learn more about it.
Yeah, I remember the conversation. It's always hard for me not to evangelize the products that I'm working on. But in the case of a stealth startup, you kind of have to dial it down a notch. So it's really wonderful to have been able to launch the product and the company and put it out in the open and see the wonderful reception that folks have had, but also just to get out and talk about it and have conversations like these. So thank you for having me on.
I wanted to start a little bit about you. I read on the Pila website that you grew up in New Orleans and that Hurricane Katrina, now 20 years ago or so, was a big inspiration for you and what sort of drove you to this career focus of building energy resilience. I was hoping you could say a little bit more about that. Like, what was it about that big event that drove you down this path?
It's the 20th anniversary this year in August. So meaningful year for folks that lived through that. It set the seed for me. I mean, you experience what infrastructure collapse, infrastructure failure looks like and what it feels like. And it's not good. Kind of hard to forget those kind of moments. And yeah, for me, it was a bit formative. I think there's this invisible network of things kind of keeping our life running smoothly that we're lucky enough to take for granted most of the time. But in those moments where it, in a blink of an eye, kind of disappears, you're awakened to those systems. And for me, it was as a moment of kind of curiosity, like, what are these systems? How did we build these? Can we build them better? So studied engineering, and it's been a learning journey ever since then through the kind of product development, deployment side of this. But ultimately, the most important lens that we all have is the human lens here. And like, what are we building and how is it improving the way people exist and live in the world? And how are we thinking about comfort, convenience, health, well-being, and all of the rest? And once I got started on that path, it was very hard to diverge from it because I think it's meaningful to meet people where they're at with these sort of needs.
Yeah. And it feels like you kind of nailed it pretty well working at Powerwall and Span. Like those are products that really hit on this challenge really well. I'm curious, kind of having had that experience, what was it that motivated you to go do something different than what those companies were doing? What were you saying?
Yeah, absolutely. And as I reflect on it, like, man, was I lucky to get the opportunity to work at those companies and to build innovative products at the right time. A lot of this technology, or I should say the application of it, is new in homes and buildings. Powerwall only launched in 2016. So we're really kind of living through a really exciting time for upgrading infrastructure, and like everything's moving to the edge, and now it's AI, but that trend has kind of kicked off in the last decade and it's not slowing down. So Tesla really pioneered the home battery system as we know it today. Prior to the Powerwall battery, which for folks who aren't familiar, it's a very sleek battery that kind of bolts onto the wall in your garage. And there's some other interesting hardware to meter your energy. And the software that wraps all of that helps optimize your energy usage. In an outage, it'll automatically protect you, kind of like a generator. But during the rest of the year, it's charging from solar, it's managing your utility bill and kind of giving you all this unique insight into your home that like none of us have historically had. So Tesla set that in motion and moved us away from lead acid battery arrays with charge controllers in a shed. And the battery backup wasn't a new concept, but thinking about it as something that could be productized and mainstream was new. And I think that was the real innovation on the Tesla Energy team. The Powerwall itself really, at least as I see it, was sort of a solar accessory, right? You, as a likely Tesla customer, had an electric vehicle. The solar was a way to kind of charge your car for free at home and reduce your dependence on the grid. And the stationary battery, the Powerwall, stored that solar energy when you weren't home, and then also gave the kind of backup power resilience value prop. But the deployment story is where a lot of this starts to hit the friction points, right? Like, sounds great, I'm in. A lot of customers start there, and then they start down the path of trying to get it. And truly, it's one of like the biggest electrical upgrades you can undertake for your home. And then let's also not miss the point that you have to own the home, right? To pull the permit and upgrade. So for folks that have HOAs and live in condos or rent, they're generally not even setting their foot past the door jamb in this process.
Right. You're not going to put a Powerwall on your rental home or apartment or anything. Yeah.
Yeah. I've yet to meet anyone that has convinced their landlord to do that for them, but there's other reasons that you might not want to do it either, because it's an expensive solution for that size of dwelling and a whole host of other like deep technical things like 208 voltage versus 240. But the process is long. It's a multi-month for many folks process to go through sale, bespoke design, permitting, permission to operate with the utility. And there's a lot of soft cost baked in to all of that. Like today, it's over 50% of the cost that you're going to pay to get a whole home battery is soft cost. Despite battery prices coming down, despite this tech getting cheaper, there's this kind of labor, very manual, bespoke process to get it installed. And what does that mean? Long story short, not a lot of folks have taken the leap. There's a few 100,000 homes in the US that have gotten a whole home battery, which includes companies like Tesla, Enphase, SolarEdge. There's now many of these on the market. And it's odd because power outages are getting worse. Energy prices are going up kind of across the board. The need is getting higher, but we've kind of been linearly scaling this product architecture of whole home garage battery for the last 10 years. We saw the opportunity to kind of do it different with Pila.
Yeah. I mean, I can say personally, I've kind of stepped into that process and stepped out once I realized how expensive and involved it would be. It just didn't pencil for me.
Yeah. And it's not uncommon. That's what people are by and large experiencing. And crude analogy, but let's imagine that we deleted all of the plug-in hybrid options for vehicles from the road. We delete all the regular hybrids. We remove level 1 EV chargers, the plug-in style. And we suddenly tell people your only option if you want a better driving experience is to go full electric, and you have to have a fixed level 2, 240 volt, $5,000 EV charger. What would that do to adoption of the technology? Like, you've just yanked out the on-ramps for folks. That's the EV analogy. But today, that's the reality in home batteries, right? In smart home backup batteries is there's really only the level 10 option. And most folks are starting at 0. We have to ask ourselves, like, how do we create these on-ramps? How do we meet people where they're at? And this concept of scalable, distributed batteries placed where power is most important to you, I see as really the perfect solution to that. And honestly, the obvious solution to that.
Is there anything else that's kind of changed in the world other than you kind of having this insight based on your career experience that makes now the right time for Pila to exist?
Yeah, absolutely. I mean, we can talk about the technology evolution. Like, of course, these batteries have become not only less expensive to put into product, but the safety margins have gone way up on LFP batteries as we've scaled energy storage across the grid. The wireless communication technology that forms the basis of our mesh has evolved quite a bit from IoT 1.0 days where everything's a spotty Wi-Fi connection kind of thing. And then, of course, like embedded compute costs have come down as well. So we've baked all of that into our product, and we've been able to move quickly because it's never been more available. And it's not to say that all of these pieces are created equal from all manufacturers, but if you know who to work with and who to partner with to put the right products together and wrap it in your own design, you can end up with really cost-effective and performant products. And for us, performant means infrastructure grade, right? What we're building, we don't think of it quite so much as a consumer widget, even though it's wrapped in a beautiful design and has great app and features. The underlying tech is very much infrastructure grade. And that means like the temperature ranges that it can survive, the lifetime that the products will survive in the field, and the kind of guaranteed uptime of things like communication and processor and things like that. So technology side, and then a moment ago, we talked about what's going on in the world, right? With outages and electricity prices. And I think just general awareness of home energy. So put those two things together and it's the right time.
It's helpful to think of it as like an on-ramp to energy storage. And just to quantify that, I was looking at your pricing versus a Powerwall, just as like a quick comparison in it. You're about a tenth the cost or something, right?
Yeah, about a tenth the cost, about a tenth the size. The hardware cost, say it scales pretty linearly. The install cost and the soft cost and all of the rest are really where we focused on bringing down the total cost to the customer, in addition to the upfront cost, right? Just being able to start small, start where you need it. A really great analogy, I think, is in the home audio space. And I talk about this all the time. The sort of Amazon Sonos distributed speakers throughout your home, they've taken over, right? Because you can build out the system that's right for you, and that can change over time, but you can get started. And then these are also integrated parts of your home. It's not like you're carrying around a portable rechargeable speaker with you. It's always ready to go when you walk in the door and when you're away. But you're not having to call a professional installer who's punching holes in your drywall to put speaker cones into the wall with the volume dials next to the light switch kind of thing. So this concept of permanent devices that you own that are portable and integrated, I think is really powerful. And we've seen that like smart thermostats, you name it, right? I think that we're seeing an up-leveling of products kind of across the board in the home that maybe used to be thought of as fixed infrastructure because centralizing the computation and the communication and the design of the product was a requirement to make the product make sense. And that's no longer true, which is really exciting.
I like that Sonos analogy. That's really good. And then I guess the other thing is back to your renter example, like you own this, it lives with you. If you move to a new home, you just bring this with you and plug it in the new house, right?
Yeah, absolutely. And again, solar and Powerwall and home batteries, the sale is often a kind of payback sale. If you've had the door knocker come to your house, they'll show you a line and you're going to hit a 7-year payback on this and then you'll be printing money, right? Like in a lot of cases that can be true. But even if it is true, the payback is typically in that like optimistically 5, more often 7 to 9 year, could be 10-year plus payback. And then average home tenure rates are around 5 years now. So if you bolt this thing to your wall, are you really going to realize the savings value of it versus a system that you can take with you when you move? I think there's kind of obvious value in owning it.
When we think about it in kind of the context of climate change, is it more accurate to think of this as kind of a climate change resilience solution? Like this is helping us maintain power to critical appliances when power outages are becoming more frequent, like you said. Or, and maybe the answer is both, or is it a climate change fighting solution in that it's helping us take better advantage of intermittent renewable energy on the grid and take better advantage of rooftop solar and small solar systems behind the meter and that kind of thing? Like, how do you think about this relative to climate change specifically?
The picture that's coming to mind for me is like the Maslow hierarchy. Like when you talk about human needs, like first we need shelter, and then at the top of the pyramid, it's self-actualization and friendship and all of that. Like what is the Maslow hierarchy of needs for surviving in a changing climate? I think first we need to be able to be comfortable and adapt, right? We need Wi-Fi to work. We need to be able to communicate with people around us. So power resiliency, I think, underpins like everything, right? We're not going to be able to do anything about it if the grid is collapsed. So let's solve that first. That's kind of always, for me, why the backup power resiliency use case is so powerful. And it's frankly like why I think, and I've observed people buy and invest in these even 5-figure investments for a whole home battery. The stack on top is great, but very few people care about their house being a virtual power plant that's assisting the grid and the rest. They care a lot about making sure their family is safe and they can kind of continue living their life. So we start there, but it doesn't stop there. This isn't a backup solution a la pull start generator or camping battery in your garage that's collecting dust 99% of the year. And you hope it works in the outage. This is something that's always ready to go. We've solved the outage problem. You've got this persistent device that's ready to go. What else can it be doing for you in the background? And this is insight from both Tesla and Span. Once you have a persistent device, you can do more. And you can do the things that you mentioned, right? Storing solar that you generate on site, charging and discharging these batteries together to save you money on your bill in a situation where the price of electricity is changing throughout the day, which is true for us in California. And then ultimately, like helping the grid. And that's something that, like, by the way, you can get paid to do by opting into those programs. So our system is kind of designed to hit the high watermark on that value stack. But I think we're also very practical about why people are deciding to invite these products into their home and make the investment. And we want to speak very honestly about what that is. And then from there, we can work up into the additional value, and the hardware is very capable of it. But when the problem is we need more of these out in the world, we got to start with why people want them in the first place.
Right. It's not enough to say this is good for the world. It's got to be good for the people actually buying and installing them. Yeah. I talked to Sam D'Amico at Impulse, and he described it. So just quickly, they put batteries in stovetops, but he described it as like almost a sneaky way to get a lot of energy storage on the grid. Because if you have lots and lots of homes buying small batteries, eventually that adds up to like this really big total energy storage number on the grid. Is that kind of a good way to think about this as well? Yeah.
Yeah. I mean, by the napkin math, if you could snap your fingers and imagine a world where every home had a battery like Pila 1.5 kilowatt hours, kind of in one location that mattered a lot to them, whether it was their fridge, sump pump, home office, terrarium protecting their heat lamp on their lizard, which is one I've heard, right? If we had one of these batteries in every home, we would hit almost 10x the total grid connected battery capacity today. In other words, the sum of all power walls in homes, the sum of all container-sized grid batteries next to solar fields. So there's a lot of power in distributed scale. And the wonderful thing about what we're doing and what folks like Impulse are doing is by getting the batteries all the way to the edge of the grid, you can actually do more. The further you are towards that end load, the more you're able to serve the backup power needs, shift energy management, again, to save money. But you can also get really interesting data. And for us, we think about the appliances that we're powered and connecting to. Typically, these aren't smart appliances, right? You're able to tell people things that matter to them that they haven't maybe known that they wanted to know before, like food safety and temperature kind of in the refrigerator, usage of these other high power appliances. And the software that we've developed is like really powerful. We can develop these virtual twins of the appliances from data like power, temperature, and more to predict when the thing is going to fail. And ultimately, it's like about saving people headache. The outage is a headache, but there are also all of these kind of day-to-day challenges beyond backup power that we leave a little bit more to chance than I think need to be.
How do you do temperature in the fridge?
We've got these AirTag like wireless temperature sensors that you just chuck in the freezer and the fridge. So pretty simple solution. But the great thing about it is it's inexpensive and it works for all fridges versus needing the latest and greatest smart fridge that with some hacky pairing process.
That's cool. I want to talk a little bit more about just kind of how it works. And I'm curious if you could just walk through like what the setup looks like. So I order a battery, shows up at my house. I plug it in. I plug my fridge into the battery. I plug the battery into the outlet.
Bingo.
Put the battery on top of my fridge.
Easy as that. If you've ever plugged in a power strip, right, you can absolutely set Pila up. This is not a product for engineers only. Power passes through, right? So it's connected to your home and ultimately the grid via a standard power outlet. So first thing is you plug in the battery, then you place it wherever power is most important to you. And we've got a very slim design that can sit on top of the fridge or in a cabinet. It mounts to the wall. It's very flexible in that sense. Fridge, whatever else, plugs into this device. And we have some accessories to make that really easy. For example, if you care a lot about your countertop appliances and you've got this battery in a cabinet, we have a really sleek kind of backsplash mountable smart power strip as well. All of the outlets on the device are smart, meaning you can control them with software via the app on off, but we also measure power in and out. So in the outage scenario, power cuts, all of these across your home today will kind of become independent islands of power. So you'll have your kitchen island of power, you'll have your den island of power. When the grid's up, 99% of the time, the batteries are all connected via your home wiring, right? So they can communicate via the mesh, decide when to charge, when to send power to the load, and in that way, manage your whole home energy usage.
Sorry, they're connected via the home wiring, meaning you're communicating over your power lines in the home, not over wireless?
Not power line communication. They're electrically connected through the home wiring, and then they actually talk to each other through a pretty novel sub-gigahertz mesh network that we've developed that's able to kind of punch through any wall and ensure really reliable communication. But yeah, electrically through the home. And that means they're also electrically connected to your solar system if you happen to have rooftop solar. And just like a Powerwall, which measures the output of your solar inverter and times when it charges to soak up that power. We call it AC coupling. In the industry, Pila is the same.
Help me understand the value of them being mesh connected. What do I get out of being able to kind of communicate with each other?
Yeah, it starts with setup and expansion, but really at the end of the day, it's about reliable up to 10-year kind of set and forget performance so that we can treat these batteries like infrastructure. Let me step through that. From the setup perspective, it's you plug in the second battery after you set up the first one, they'll automatically kind of recognize each other and form the network and kind of extend the network throughout your home. If a battery drops off, traffic is rerouted and they can automatically kind of heal from that like single point failure. It's a lot like your mesh Wi-Fi systems kind of thing. So it saves in setup. It also means a year from now, when you buy your second, third, or fourth Pila battery, the same will be true. We're taking on that hard kind of configuration setup task so that it truly is like plug in one click. Once you've got it set up, it's about coordination. And that means charging the batteries, discharging them together, and deciding which battery might be getting the solar production that's happening on your roof at a given time based on what's most important to you to back up or manage the energy kind of thing. Fridge might be more important than den TV kind of thing. The mesh is all local, right? So this isn't like a cloud communication kind of thing where when the tree branch severs the power line coming into your house, it also severs your internet and these things become dumb bricks. Right? We've designed it as a resilient local system so that in an outage, you can get a whole home picture of what's going on in that outage, how much backup time you have for each load, and then kind of make decisions about how to extend your backup time.
It's backing up anything that's plugged into the battery. Is that
yes.
How it works? Okay. And what you say today, what's the kind of future state?
The sort of straightforward power passes through model. It's our starting point because there's no hurdles to doing that in the world we live in now. The exciting thing is bidirectional power through outlets in the home and in businesses is coming to the States. This has been a thing in Europe and in Germany for several years now, a trend called balcony solar, where you have these solar panels. Maybe you live in a condo and you hang them off your balcony, plug them right into an outlet, and that sends power into your home, offsets your usage, saves you money on your bill. So there's nothing inherently unsafe about this, but like anything electrical, there's the right kind of practices to do it in a reliable kind of way. So Utah, just this past month, passed the first House bill putting forward balcony solar in the US. That's really exciting because now it means condos, renters, and cost-conscious households can kind of benefit from this energy savings and ultimately like resiliency benefit in ways that they wouldn't have been able to before. So it's early days, but this idea of sending power back, which to your original question is a way that you can back up the entire home with these plug-in batteries, is in its infancy. But I like to remind folks that when we launched Powerwall, sending power back from a big battery in your garage also wasn't quite streamlined. In some places wasn't allowed and the rest. And this is just the pace of progress in a regulated industry that's very focused on safety. And hey, we're excited to be partnering with those agencies and thinking about the safety aspect together and thinking about how we advance the codes and standards in a reliable way.
So it's really a regulatory hurdle more than a technical hurdle.
For sending power back, absolutely. And then in the case of whole home backup, I'm sure there'll be really sharp listeners who are thinking like, what about the microgrid interconnection device and the automatic transfer switch and the rest? And ultimately, you want to make sure your house and whatever you're powering in an outage is disconnected from the grid so that you're not shocking linemen who are doing repair work. So there are other components to kind of enable it. But at the end of the day, there are paths to use these batteries that are distributed to work together to kind of collectively keep power on in a premises in a safe way. And we're incredibly excited to be pushing at the forefront there.
Okay, cool. So as a user, the benefit to me would be very similar to a whole house battery sitting in my garage like a Powerwall, but I've gotten there by kind of plugging in 5 to 10 of these batteries around my house wherever is convenient and just plugging them right into the outlet.
That's right. Yeah, that is a future that we believe will arise and not in the distant future.
So you started this company within the last year, right?
Yeah, a year ago. This
Okay.
month.
Okay. You're a year in, you've announced these products, you can go to your website. Like you said, they're beautiful, like really well designed looking products. You've got the battery, the power strip, the temperature sensor you were just saying. It sounds like you've made a lot of progress in a short amount of time. What have been some of the biggest challenges in getting these sort of novel hardware products from kind of early concept where you started to where you're at now, where I think you're ready to ship in the next, what's your shipping time frame?
Later this year, later 2025, we'll be shipping to first customers in the US.
So yeah, I'm just curious, like on that path, what have been some of the big challenges in the product development journey?
Such a good question. And there have been many, right? Everything from kind of tech selection and like, where are you placing your bets? There are a lot of wireless technologies out there, and we've been really intentional about which ones we've gone with, and that's come through testing in real world environments and borrowing learnings from past products. The foundations, right, that kind of really allow you to move fast are where we've been focused and kind of pacing through these challenges one by one, whether it's the bidirectional architecture of the power electronics system, whether it's the layout, the distribution of compute and microprocessors throughout the device. It's always kind of like a hardware versus software trade-off that you end up making to either go fast or create products that are really flexible and can be over-the-air updated 10 years on kind of thing. And by and large, we've optimized for those paths, but each of those have their own set of kind of design challenges. Packaging everything into a small package, always challenges there, and a lot of creativity required in board layout and kind of custom design there. But I feel very fortunate to be working with really talented engineers who have stepped up and embraced the challenge here. And then as we move out of the design phase and testing phase into the mass production phase, I'm sure you and your listeners are well aware of the challenges that you have in scaling a global supply chain in 2025. But the beautiful thing is there's not a lot of new hardware science needed to realize this type of product. And that was true at Span, where we were relying on mature, reliable technology, but put into a new application and form factor. And the exact same thing was true at Tesla, right? Which used cylindrical lithium ion cells from mature supply chains, but packed with intelligence and all of the rest.
That's a great answer. One thing that stood out to me was just the cost. And I was curious if that was a challenge, not in a good way. I was surprised that you've hit a cost per kilowatt hour kind of on par or even lower than the installed cost of a Powerwall. I think it's like $800 a kilowatt hour ish for your product versus around 1,000 or more for an installed Powerwall. But I just feel like you don't have the economies of scale, both in terms of the size of the battery and the product and the volumes of products. So I was just curious if cost has been a challenge and how you were able to achieve that.
Cost is always something you end up talking about endlessly in hardware development. So I'd be lying if I said no, but we have been able to kind of scale down cost with capacity versus existing solutions. And I think that's honestly just a testament to global supply chain evolution and the fact that we're working with vendors who are best in class and have been able to forge partnerships in this space with folks who are excited about what we're doing and creating a new product category. And I think that's a lesson, right? Where a lot of this, there is so much opportunity to partner with folks in the space across the engineering, design, and ultimately supply space when you're doing something new and innovative, because everyone stands to benefit. So that's part of the cost story. And then beyond that, there's no smoke and mirrors. You have to optimize your supply chain. You have to make good design decisions out of the gate, trading off features and benefits. And again, I feel very lucky to be working with the Pila engineering team that we have, who are masters in their craft at doing that optimization. So despite our early days here, the knowledge and the experience of the team goes much further back.
That's awesome. The other thing I was thinking about with your business is I know that it can be challenging to build a consumer brand from scratch and scale sales to direct to consumers, and to have the kind of impact that Pila has the potential for. You need a lot of scale, right? You need to ship a lot of batteries and have a lot of batteries installed in homes. I'm curious, I know I can go to your website today and start to reserve a battery. Do you have other strategies for kind of getting to the type of scale that Pila has the potential for? I imagine partnering with appliance manufacturers or with multi-tenant apartment complexes or cities or something like that. Like, how do you get to that kind of massive kind of scale that has the impact we've been talking about?
Yeah, I mean, if we jump all the way to the end of the story that I would like to see here, we're removing as much decision-making friction from the process as possible. And that means that we're just building our homes and buildings in better ways, and building devices that go into those homes and machines that go into those buildings in better ways. And we've seen the proliferation of $3 Wi-Fi radios and the rest into kind of every device by default. And my belief is that batteries can follow that same trajectory of finding their way into all of these critical devices, spaces, buildings. And it's why we think about the platform value of what we're building, not only being, okay, it's beautiful design, but also it's the kind of core technology and the communication and the rest, because that's how you get maximum value and utility out of all of those batteries that become embedded by default. As folks we've all probably had our frustrations with quote unquote smart appliances that have a Wi-Fi radio, but don't really quite do what you want because the software is not there. All too common. It really is a combination of hardware, architecture and design, and software that actually makes these products deliver the value. And for us, that's like the grid integration and energy management we talked about earlier. So the future I would like to see is all of these batteries that make their way from mines and dug out of the ground as minerals through manufacturing and into these products are useful, so that we have to dig fewer mines and manufacture fewer ultimately. And we're being smart about resources. And when you think about that as being a software problem at the end of the day, it feels like really solvable with the right set of technology and solutions and just thinking intelligently about these products. So everything you mentioned, I think, is the future that we'll see. We will bring multi-tenant buildings under this tent. This is not just a single family owner occupied home type of journey. And Pila and the technology that we're building, I see as kind of foundational to get there.
In that future state where kind of everything has a battery and they're all talking together, where does Pila play in that? Is it where these are Pila batteries inside appliances I'm buying? Is it Pila is kind of that platform that connects everything together? Where do you want to play in that?
I expect there to be opportunities across the whole stack. At the end of the day, the hardware components, if we're doing this right, will become more and more commoditized and therefore cost effective to deploy, which naturally, if we look at anyone, whether it's like networking equipment and Wi-Fi and the rest, like the hardware becomes cheap and replicable. The software and the kind of application layer, the integrations, and maybe certain hardware components are really where we want to focus and have kind of staked our claim. And it's why we didn't go build a battery manufacturing line on day zero to do this. We're focusing on that design and application layer. And that's a core part of our DNA. And I expect that to continue to be a core part of our DNA, making sure all of these things work together, making sure they're architected to be able to do all of these cool features like managing power across an entire building, which is not, it's not a given in every kind of electrical design and power electronics topology. So that's a more general answer than maybe you were looking for, but at least on the pod today, that's what I can share.
Yeah. I figured. Maybe just to like challenge it or question it a little bit to make sure I understand that kind of what you're saying. So is a different future state one where we have either plenty of clean baseload energy on the grid or lots of energy storage on the grid to the point where the grid is very resilient and stable and pricing is, we don't have this kind of intermittency issue and it's reliable and there aren't as many power outages. So you don't need the kind of behind the meter resilience that we're talking about. Is that a different path or is this we have to do both kind of thing?
I think it's an all of the above solution. I would certainly not get on a soapbox and say, let's stop installing power plants and the rest. I think our aging grid needs all the love it can get. The value of batteries in buildings and homes, though, is higher than big container-sized batteries on the grid because they can deliver the backup power. And even in markets that have really reliable grids, everyone struggles with outages. The box truck backing into your home and the rest. And when this tech becomes cheap enough, I think we'd all appreciate default protection from that kind of thing. But even past outages, the kind of energy management, right? Managing your usage so that it's cost effective, you're timing it ideally with those cleaner sources and not impacting your comfort and convenience or making any compromises, while also giving you more data and insight around what these key pieces of infrastructure and machines in our homes and businesses are doing, right? The failure prediction value, did I leave the fridge door open type of value. I think all of those things continue to be true, even in a world where we've snapped our fingers and kind of solved the clean generation problem on the grid.
Which is probably not very realistic anyway.
Hey, we can dream.
Yeah. Okay, got it. That makes a lot of sense. So I have 3 questions I ask everybody at the end of each episode. The first is how optimistic or pessimistic are you about the future of the planet and why?
I'm an optimist by default. I don't think everything is easy breezy and it's not going to be a walk in the park to get there. But I think there are so many smart people working hard to solve real problems. And honestly, maybe more so than ever. I'm bullish. I'm optimistic. 100 years from now, it will be a better world, not a worse world.
Nice. Who's another company or individual doing something to address climate change that's inspiring you?
I think the most inspiring thing I've seen recently, and it's not an individual, but just a trend of seeing like younger folks who are maybe high school age and the rest kind of using platforms like social media to kind of get out and talk about local problems in their area. There's always been this want to talk with like a grand vision of the future and what's going to happen, but so much impact is realized at the local level. I think that clicked in my brain and has made me think a lot more about what can I be doing locally. And I was really inspired to see like younger folks kind of naturally intuiting that and spreading that message. Everything from local parks and conservation to just water supply issues in their very local area. Really inspiring to me.
That has definitely stood out to me too, just how engaged in these kinds of issues people younger than me are. What advice do you have for someone not working in climate today who wants to do something to help?
If you're looking to break into the climate space, just do it. Like find a foothold. It doesn't have to be the dream job you think you'll want in 3 years, but especially if there's a company or set of companies working in an area you're interested in, get your foot in the door, whatever job it is, whether it's support or actually support's one of the best ways to learn about a new product space because you hear from real customers. Whatever it is, just make the jump. That was part of my story. And I think there's so much opportunity here that anyone interested in the space certainly can find their place. You don't have to be an engineer. You don't have to be a hardware person. I'm certain there's space in all manner of different ways. So listening to podcasts like this, honestly, great answer too. It was a big part of my early route into companies like Tesla. It was like paying attention. What's going on? What are the trends? And educating yourself, right? So that you have something interesting to say after thinking about this stuff and processing it. That's kind of where it starts.
Awesome. Thank you very much for your time. That was really fun. I love what you're doing. I want to get one. I want to get a Pila battery. Appreciate it.
Thanks, Dylan. We'll sign you up and let me know what color option you opt for when you do.
Awesome. Thanks, Cole.
Yeah, my pleasure.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.